Good morning, grade 9s. We are going to get started with our lesson for today. We will see how the lesson goes today. Hopefully no technical difficulties. I'm going to get started, and the lesson for today is titled Graphing Inequalities. So you should all right now, and I'm going to show you right now, I'm going to be scrolling kind of to the bottom here where I do have your worksheet. You should have your worksheet in front of you. As we kind of go through this, what we'll do, actually, you know what? At the very end, I will give you the summary. We'll go at the very end, once we've kind of completed this, we will take a look at the summary here and do a little fill in that. So just for now, just follow along, try to kind of take in what I'm talking about, and then we'll do the summary at the end. And there's a few questions for you to practice once we complete this. All right, here we go. So, graphing inequalities. So far what we've been doing is we have, in this course so far, been graphing equations, right? We have been graphing equations. And the difference between equations and inequalities, an equation would be something like y equals 2x plus 5. And an inequality would be something like y is less than 2x plus 5. So notice that in appearance, these two things appear to be very similar. Obviously, our key difference here is in one we have an equal sign, and in the other we have an inequality symbol. Okay, so this is kind of the key difference. The graphing process is going to be very similar. There's going to be two key differences that we're going to have to talk about. Okay, so let's get started. So the first question here does say, and we've done something like this earlier in the year, the first question here says, do the following points satisfy the inequality? So I'm going to show you how to do the first one, and then you can maybe pause the video or try the next two, or just keep the video playing, and we can kind of test them all out. But basically what we're going to do here is, in each of these, we have an x coordinate and a y coordinate. And so what I'm going to do for each of them is I'm going to substitute my x and my y into my equation here. Okay, so this looks like -2 is greater than 3 bracket 5 minus 4. Now, we're going to simplify this, or simplify the other side. So 3 times 5 is 15, minus 4. We have -2 is greater than, that's 15 minus 4, which is 11. Is -2 greater than 11? No, it is not. -2 is definitely less than 11. So this point does not satisfy. Okay. Excuse me. Let's take a look at the next one. Same idea here. We are going to sub in -4, and for y, it is saying it's greater than, that's 3 bracket -3 minus 4. All right, we have -4 is greater than 3 times -3, that's -9, minus 4, that's -4 is greater than -13. Is -4 greater than -13? Yes. If I am -$4 in debt and my friend is -$13 in debt, I definitely have, we would say maybe, I guess, more money than him. Not really more money, but I'm in better shape, I guess. All right, and the last one here is, so this one, sorry, that one does satisfy. Now the last one here, -5, 6, so same idea. Oh my gosh, I'm going to be careful here. All right, we're going to sub in 6. We have 6 is greater than 3, bracket -5, minus 4. Same idea, we're going to simplify. We have 3 times -5, which is -15, and minus 4. That 6 is greater than -19. This one does, in fact, satisfy. So we are all set there. We can kind of check those by substituting the numbers in. Now, I didn't really give you an opportunity to pause that video. I kind of went fast through those. But feel free to pause the video at any point here. Okay. Solve the following inequalities. So, again, what we want to do here is we want to solve for x. And the second one, we want to solve for y. Now, you may remember this from our algebra unit. When we are solving an inequality, the process is very, very similar to the process of solving an equation. We are going to isolate for the variable. So in the first one, I have 2x plus 6 is greater than 10. What I'm going to do here is I'm going to bring my 6 to the other side, where it becomes a minus 6. If it switches sides, it switches signs. We have a 2x is greater than 10 minus 6 is 4. My last step here is I have to get rid of that 2 in front, so I'm going to divide both sides by 2 because I am currently multiplying by 2 there. Those 2's cancel out, and we have that x is greater than 2. So that is my solution for the inequality. Now, you can pause the video here and try the next one. Okay. If we paused it and are ready to go, that's fantastic. If you didn't pause, that is also fine. All right, so here we go. Same idea with this one. I'm going to bring my negative 4 to the right side, where it becomes a plus 4. We then get 3y is less than 17 plus 4 is 21. Oh, I'm missing something. Negative 3y. Now, here's the big trick with these questions. When I need to divide by a negative, so in this case, I have negative 3 times y. I need to get rid of the negative 3. So I'm going to divide both sides by negative 3. When we divide by a negative, this is the only difference with solving an inequality versus solving an equation. When I divide by that negative, my sign will change direction. So I get y is not less than anymore. It's now greater than, and that's negative 7. And there's my solution there. So we did do those earlier in the semester, but that's kind of our main idea there. Okay. Next question. So refresher. Again, we're doing a few different things here. That's the most start of this lesson is mostly a couple of refresher things for us. What you can do right now is you can pause the video and try to isolate for y in both of these equations. So rearrange those formulas and try to isolate for y. I'll give you a second here. I'll say pause the video. Okay, maybe we've restarted that video or got it going again. And here we go. I'm going to isolate for y. I want it in the form y equals mx plus b. We did a little bit of this yesterday. My first step, remember, I want to leave y. I do not want to move y. You could, but we generally don't want to. I'm going to bring my 3. I'm going to bring it over to this side. My y stays where it is, so that stays as minus 2y. I did not change that. I did not move that. Equals my 3x changed sides. So when it changes sides, it changes signs. So that becomes negative 3x. And my 12 didn't move, so it stays as a plus 12 or positive 12. My next step here is I need to get rid of that negative 2 in front. So what I'm going to do is I'm going to divide every single thing here by negative 2. Now, I get my final equation of y equals. Now, we're going to leave 3 over 2 as a fraction, but just notice here that since I have a negative on the top and a negative on the bottom, a negative divided by a negative is a positive. So I'm actually going to cancel those negatives out, and I have 3 over 2x, and that's 12 divided by negative 2, which is negative 6. There's my first equation. We're going to graph that in a moment. With the next one, same idea. We're isolating for y. We're trying to get y by itself. In this one, I have 2 things that I need to move. I need to move my 4x to the one side, and I need to move my negative 16 to the other side. Moving both of those, we got our equation becomes 2y equals, that's negative 4x plus 16, right? Change sides, change signs. We're going to get y by itself by dividing both sides, everything by 2. These cancel out. We are left with y equals negative 4 divided by 2 is negative 2 over 1. I'm going to keep it as a fraction because we are going to be graphing it. and that becomes plus 8. Whoa. Just going to try to box that so I don't cross everything out. Beautiful. Now, we're going to graph these lines, okay? So what these graphs look like is the second one. I'll start with the second one in red because I got my red out. We're going to go -8 is my y-intercept. And this graph is going to go, it's -2/1. So it's going to start at 8 and go down to right 1. So down to right 1. Now I ran out of space, so I'm going to go the opposite direction. I'm going to up to left 1, up to left 1. And when I do that, I get like a nice... I find it really hard to draw straight lines unless I have all those dots here. So I'm going to draw all... Whoa. I do struggle with this. Let's see here. Sometimes making the line a little bigger makes it a little easier. I don't have a ruler on me either. All right, there we go. There's our first one. Let's do the blue one. The blue one starts at -6, right? So it's going to start at -6 on the y-axis, and it's going to go up 3, right 2 because of my slope. And so we're going to go up 3, right 2, up 3, right 2, up 3, right 2, up 3, right 2. I could go the other way too, down 3, left 2, and I should get form a nice line. There we go. Okay. So hopefully that is a little bit of a refresher on what we've been doing the last week or so. And now what we're going to do is we are going to graph some lines. Now, what you could do here, and if I was in class, what we would do is I would give you an opportunity right now to maybe using Desmos, or we would do it on the computer or on the computers, is I would get you to actually type these equations into Desmos, okay? But I'm not here, so what we are going to do is we're just going to graph some. Okay. Oh, there we go. Well, this is what they would look like. So if I were to put these into Desmos, this is what these equations would look like, okay? The first one is just the regular equation of a line. I'm going to zoom in on it. Well, actually, no, I want you to see all of these. First one is just the regular equation. It has a y-intercept of 1 and a slope of 2/1. It goes up 2/1, up 2/1, okay? So that one's pretty straightforward. Now, the trick here is that the next one, the rest of them change. So notice that the first one is the only one that is an actual equation. The rest of them are inequalities. Okay? Now, what I want to focus on here is kind of what is happening in each line. If you want, you can pause the video and maybe discuss with your neighbors what you notice about these graphs. Okay, if you notice any similarities or differences. If not, we can look at each of these in particular. Okay, I want to point out two things. One is the obvious difference or thing about the inequality ones is that half of the graph is shaded in or colored. Okay. Now, the key thing to look at here is to look at the inequality, the direction of the inequality, okay? In the very first one, and they're in the one top right, if I were to read the one in the top right, it would say y is, well, let's make that a little bit neater here. I would read that as y is greater than. That's how I would read that. Y is greater than 2x plus 1. And notice that the part that I have shaded in here are all the points or all the parts of the graph that are above the line, okay? Like if I put any points, if I plot some points, like let me mark down some points, like this point here, That point is above the graph. This point here, that point is above the line. This point here, that point is above the line. This point here, that point is above the line. This point here, that point is above the line. Basically, all of the points here are all above the line. Okay, that's because the equation or the inequality says y is greater than. In the next two, you can see that the next two say y is less than. Or in this, in the last one says y is less than, right? If I were to read that. And in these ones, right, same idea. If I pick points, the points that I'm picking are all below the line, right? This is below the line, below the line, below the line. Okay, all of those points are below the line. So technically, the entire shaded region is entirely below the line. Okay, and this is how we graph or represent an inequality, is we graph our line. Okay, maybe you notice here that all of the lines look the exact same because they're all 2x plus 1. We graph the line and then we shade in the region either above the line if it says y is greater than, or below the line if it says y is less than. Okay, so that's our first really key difference here. Now, the second key difference is if you look a little closer at the lines, you probably notice that two of those lines are dotted, and two of the lines are solid. Okay, now think about it for a second. What do the lines that are dotted, what do the equations of the dotted lines have in common, and what do the equations of the solid lines have in common? Okay, the first one, the first equation, the very first one up here, is solid. If I were to read that, it says y is equal to 2x plus 1. Okay? When it says it's equal, our line is solid. In the second one, it's y is greater than. It doesn't say greater than or equal to. It's just a greater than symbol. So because it's not equal to, my line is dotted. In the next one, we also have a dotted line. That's because my inequality says y is less than. It's not the less than or equal to symbol. It's just the less than symbol. This is just the less than symbol. Now in the last one, right, this one right here, and I didn't write it, but I'm going to write it now. If I were to read this, I would read this equation, the last equation, as y is less than, or, let me change that, or equal to 2x plus 1. Notice the equal to. The equal to part tells me that my line is going to be solid. If it doesn't have the equal to part, we're going to do a dotted line. So these are the two key differences to graphing inequalities. Okay, we're going to skip past that. All right, now what we're going to do is we're going to try this. Okay, so our first thing is, our 3 steps are, you're going to determine the equation of the line. Perfect. In y equals mx plus b. The second thing you need to decide, so this is kind of your first step. We're not going to write in highlighter. That doesn't make any sense. First step, determine the equation of the line. Second step, is the line solid or dotted? And your third step is, are you shading above or below? Okay. We'll write that little summary note at the end, but let's try some examples. In the first one, okay, my very first thing is I have my line, okay? It says that my graph is 3 over 1, x minus 4. So this says I'm going to start at negative 4, and I'm going to go up 3, right 1. Okay. I'm going to plot my points. So I start at -4. I'm going to go up 3, right 1. Up 3, right 1. Up 3, right 1. Up 3, right 1. And down 3, left 1. Did I mess that one up? I messed that one up. Okay. So there's what my line's going to look like. Now I need to figure out two things. Is my line going to be dotted or solid? For this, we look at this is just greater than. It says y is greater than, not equal to. So my line is going to be dotted. Okay, I'm going to fill that in. Dotted line. It's not perfect, but it's all right. It's a dotted line. Just make sure that you're clear. It's clear that it's dotted. The next thing that I'm going to decide is, am I going to shade above or below? And with this one, for that, I look at, since it's saying y is, so this one says y is greater. I would read that as y is greater. If it's y is greater, that means it's going to be above. And so I can shade in my graph. Now what I'm going to do, I'm actually going to shade it in with my highlighter. That is above my graph. All of these points, if I were to draw any points here, these points are above the line, right? Right, that's above the line. If a point here is above the line. A point here is above the line. Okay? Perfect. That one is done. Let's try the next one. So the next one, we're going to start by figuring out how I would graph my line. So with this next one, I'm just going to rewrite this one out. The typing didn't work great. Y equals 1 over 4, x plus 7. This one we're going to start at 7 and go up 1, right 4. Okay, that's my slope. Now, same thing. Is it dotted or solid? And are we shading above or below? These are the two decisions we need to make. So it is not equal to, and I can read this, right? I can say y is greater than. It's not greater than or equal to. So because it's just greater than, again, it is dotted. So let's draw this. Oh, I should have put my points. Start at 7. Go up 1, right 4. Let's see if I can zoom in a little bit more here. Up 1, right 1, 2, 3, 4. Up 1, right 4. Down 1, left 4. Down 1, left 4. Okay, this is a dotted line, so we're going to do a nice dotted line. I can just like kind of connect the dots in here. Beautiful. Okay. And then am I going to be shading above or below? Well, this just, oh my gosh. Look at me. I apologize. I made a mistake. I wonder if anybody caught that. This is not y is greater than. This is y is less than. My apologies. It's a good thing I double checked that before I moved on. Since y is less than, we are shading below the graph. And so I am going to shade this whole section down here. And there we go. There's my next one. And my last one. Let's do one more. Y equals -4x. This is like -4x plus 0. So we are going to start at 0. And this is like -4 over 1, right? Always we got our invisible numbers there. So that's going to go down 4 and right 1. Start at 0. We're going to go down 4, right 1, down 4, right 1, or going the opposite direction. Up 4, left 1, up 4, left 1. Now we need to decide, is it dotted or solid? And is it above or below? Okay. It is, if I were to write this out or read this, we are saying y is less than, make sure I get it right this time, or equal to my equation. So less than or equal to, look at that. Since it's equal to, it is going to be a solid line. Since it's equal to, it is a solid line. So I'm going to connect these dots and create a nice solid line. It is less than, so I'm going to shade below the line. Okay. Now, where are points below the line? This one's interesting. Okay, where are points below the line? I'm going to put a point here on the y-axis, and I'm going to put a point down here on the y-axis. And I'm going to ask you all, right, which point would you say is above this line? Okay, what point is above this line? I'm hoping that we're saying the one that is at -7. Okay. Well, that one down there. And so we are going to shade in below the line. Okay. So that is our final answer there. All these points, and you can always put points on here. Put a point here on your x-axis. Tell me, is that above or below the line? I have to go, like, from the line, I have to go down to get to that point. That's below the line. Okay? If I did a point here, I would have to go up from the line to get that. That's above the line. Okay? So below and above the line. All right. Fantastic. So, let me just check. I'm going to scroll down to the homework here and just take a quick peek. Okay. I am going to do, how much time? We're almost at 30 minutes. So what I'm going to do here is I am going to do, let's see. I'm going to put these up here right now. At the front of the classroom, there should be some graph paper. What you can do right now is you could, we could pause the video. You can take 5-10 minutes to try these ones out, and then try them out on your own. And then once we've a few people have got them done, we can restart. We can put the video back on, and you can check out what these look like. And then I am going to do one of these examples here. Okay, so maybe pause the video, try these ones using graph paper in the classroom, and then restart the video. Okay. I'm assuming maybe we tried these out. I'm going to do these ones very quickly, okay? A little bit less detail here. So this one I'm starting at -4. I'm going up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. This is not equal to, so this is going to be a dotted line, okay? And this one is greater than, so in this one I'm shading above the line. Okay, the more you practice this, the faster you will get at this. Okay, so it's practice here does help. I'm going to rewrite this one as y is less than. I just like to rewrite it as a fraction like this, a little easier to see, +2. What time is it? 10:20. Okay, I got to move here. So this one's going to start at 2, and it is going to go up 1 over 3, up 1 over 3, up 1 over 3, and it is just less than, down 1 over 3, going to go this way, so this is just going to be a dotted line as well. Oh, that was the wrong point. Dotted line here. It's less than, so this one we're going to shade below the line. Okay, and the last one here, this one has a y-intercept of 0. We're going down 2 over 1, down 2 over 1, down 2 over 1. This is greater than or equal to, so this one is going to be a solid line. Sorry, less than or equal to. solid line, and it's less than, so we are shading below the line here. Okay, and that's what those three should look like. So you can check those with your work there. That's what those three should look like. Okay. Now, these ones here, a little bit different, and there are a couple like this on your worksheet. So I'm just going to go through one of these right now, okay? Just so that you have some time to practice this stuff, and then we'll summarize our note here, okay? So with these equations, now I'm going to do the second one. With these equations, notice that they're not in the form y equals mx plus b. We need to get that. We need to isolate for y like we were doing at the start of the lesson. So what I'm going to do is I'm going to get y by itself. So I'm going to first bring everything over that's not y to my right side. I get negative 3y is less than, that becomes 3x because it moved, and negative 12 because it moved. Now I'm going to divide everything by negative 3. Divide by negative 3. Divide by negative 3. When I do that, and remembering that when I divide by the negative, my inequality is going to switch directions. So I get not equals, come on. Y is greater than, 3 divided by negative 3 is negative 1x plus 4. Okay? So that's my equation now. Now that I've rearranged it, so in these questions, the rearranging is a tricky part, okay? But again, this is kind of stuff that you would see on EQAO, where they would maybe give you the graph, they would give you the equation in this form here, and then they would like ask you to match the graph. So you would need to rearrange it and then recognize, okay, this has a y-intercept of 4, and is going down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. It is not equal to, this is just greater than. So because it's just greater than, it is going to be a dotted line, dotted line. Okay, just a dotted line. And then it's greater than, so we are shading above the line here. Okay? So that's what that one looks like there. All right. So now what we're going to do is we're going to just summarize this. Okay. And then you'll have, depending on what time we got this video started up and running, you should have a good 20 minutes, I would say, at least, to do some homework questions here. If not, that's okay too. Just a reminder before I do the summary, we are going to do our our test on Wednesday next week. Okay. We'll do a little review on Monday and Tuesday, test on Wednesday. So, in summary, 4y is less than. Okay. I'm going to do a graph for each of these. Okay. 4y is less than, and I'm going to do a little equation here. I'm going to say maybe 2x plus 1. Okay. We want to know two things. Is this is less than or equal to. So when I draw this graph, it is going to be solid and below. Okay, so my graph is going to be, well, let's change my color here. My graph is going to be a solid line, and I'm going to shade, below the graph. Okay. In the next one, y is greater than or equal to. So we're going to use the same equation here. 2x plus 1. My line is going to be, again, solid. Actually, you know what I'm going to do here? No, I'm going to do the same thing. My graph is still solid because it's equal to. So this one is going to be solid. And this one is going to be and above. So I'm going to draw a solid line, and I'm going to shade above that line. Okay. Next, y is less than. In this one, I'm just going to change the direction. I'm going to change my graph to a negative 2x plus 1. I'm just going to switch the graph slightly to make it a negative slope so that you can see what it looks like with a negative slope. So that's going to be, because it's not equal to, this line is going to be dotted. And we are shading in this one, we are shading below. Okay, so this is dotted and below. And for my last one more. We're going to say y is greater than negative 2x plus 1. So that graph, again, similar to the one I just did, looks like, oh, actually that was not accurate. It's going to look more like this. So this one is going to be dotted and above. All right, so that looks like this. All right, and I think, hopefully, that summarizes it for you, okay? Now this, again, we're at the last lesson of the unit. This is a tricky lesson, okay? We've been graphing, we've graphed lots of lines this unit. We kind of finish off here with this lesson about inequalities. And this is, obviously, it adds an extra component, an extra kind of factor to deal with when we're graphing lines. But again, if your process is, like, if you remember the process, if your process is correct, okay, you should be able to do these ones or figure these ones out, okay? So what I would like you to do now is I would like you to take the rest of the class here to try out the homework. It is right here, okay? What inequality statement does each graph represent? So for each of these, you're just finding the equation of the line. So what you're going to do here is you're going to find out the equation of the line using figuring out the slope. So what's your rise and your run? Figure out your y-intercept. Write out the equation of the line. And then decide on what your inequality is. Is it this? Is it this? Is it this? Is it this? Okay. Good luck with that. Have a great weekend, everyone. And we will see you all on a Monday. Goodbye.